Hi guys, this is Mrs. Foy, and this is a quick introduction to simple mole conversions. Super important in chemistry. We're going to talk about it a lot, but this is just an introduction to get you started on being able to convert between moles and number of particles. So what is a mole in chemistry? A mole is kind of like a dozen in chemistry. In a dozen things, you have 12. In a ream, like if you had a ream of paper, that would be 500 things. A gross is a dozen. A mole is kind of like a dozen in chemistry, except instead of having 12 things, you have this ridiculously big number, 6.02 times 10 to the 23 particles. And we use this all the time in chemistry. So what's a particle in chemistry? Well, a particle could be an atom, it could be a molecule, or it could be an ion. So these are the ways that we count things in chemistry. So a mole is 6.02 times 10 to the 23 atoms. A mole is 6.02 times 10 to the 23 molecules. A mole is 6.02 times 10 to the 23 ions. So again, you can think of this as kind of like a dozen, except instead of having 12 things, it's this really big number, 6.02 times 10 to the 23 things. So don't get freaked out by this big number. It's just another equivalence. Just like 1 minute equals 60 seconds, you guys can convert with these using factor labeling all the time. This is another equivalence, right? So we can convert back and forth between moles and number of particles. So if we're counting atoms or ions or molecules, we will use this equivalence to do some conversions. So this number is so important in chemistry that we actually gave it a name. You guys know how pi is just a number, but it's really important, so it has a name. Avogadro's number is the name of this number. So there was a very important chemist, and we'll talk about him later, and his last name was Avogadro, and we honor him by giving this number a name. So Avogadro's number is 6.02 times 10 to the 23, and that is the number of things in 1 mole. So 1 mole equals Avogadro's number of things. It's kind of hard to wrap your mind around how big this is, but a mole of marbles, if you had a mole of marbles, it would be enough to cover the entire Earth to a depth of 50 miles of marbles. So you could imagine you would have a pile of marbles 50 miles deep all over the Earth. So it truly is a very, very big number. Why do we use it in chemistry? Because what we are counting is so small. So what does a mole of a chemical look like? Well, you can see it, okay? Each of these pictures is 1 mole of that chemical. So sucrose is another name for sugar. That is what 1 mole of sucrose looks like. Here is sodium chloride. That's salt. That is what 1 mole of sodium chloride looks like. So there's a really cool way that we know that there are 6.02 times 10 to the 23 molecules of sucrose in there. We know that. Trust me, we didn't count it. There's another way that you can figure that out, and we'll tell you that later. But for right now, just take it on faith that 1 mole is equal to 6.02 times 10 to the 23 things. And the reason why it looks like such a reasonable amount is because these things are so small. So we can use this equivalence. 1 mole is equal to 6.02 times 10 to the 23 atoms. We're just going to use 6.02 in this class. That's an equivalent. We can use it to do factor labeling. So here's a problem where I had 5 moles of zinc, and I wanted to know how many atoms of zinc. And so what I did was I set up this conversion factor from my equivalence. 1 mole equals 6.02 times 10 to the 23 atoms. I use this to make a conversion factor. The moles of zinc cancel, and I get atoms of zinc. And so then I just multiply 5 times 6.022 times 10 to the 23, and I got 30.1 times 10 to the 23. I moved the decimal over, and then I had to make this exponent bigger, but that's how you do these problems. So let's try to. If I had 2.5 moles of gold, how many atoms of gold is this? So what I want are atoms. I want atoms of gold, and I'm going to start off with a single unit, 2.5 moles of gold. So now I'm going to use this equivalent, and just like all factor labeling problems, I want to get rid of the unit that I don't want. So I want 1 mole on the bottom, and 6.02 times 10 to the 23. In this case, the particle is an atom that I'm counting. And so now I'm done because the moles cancel and I want atoms, and that's what I have left. So then on my calculator, I would take 2.5 times 6.02, and I would end up getting 15.05 times 10 to the 23. So I just take that exponent and just stick it down here. Atoms. Now, that is not in scientific notation, so I would have to move my decimal over 1, and if I make that bigger by a factor, I'm sorry, I just made this smaller, I went from 15 to 1.5, then I need to make the exponent bigger, okay? And so my answer is, I've got 2 sig figs, my answer is 1.5 times 10 to the 24 atoms of gold, right? Let's try another problem. Let's say if you had 4.5 times 10 to the 24 atoms of gold, how many moles of gold? So I'm going to put the unit that I want at the end of my problem. I want a single unit. I'm going to start with the single unit. 4.5 times 10 to the 24 atoms of gold. Okay, so I'm going to set up my factor labeling problem. Here is my equivalent that I'm going to use. 1 mole is equal to that many things. Guys, this is just like 1 minute equals 60 seconds. Don't get freaked out by the big number. Clearly, in this case, I'm talking about atoms, so I want to think about atoms, and I want to get rid of atoms. So I'm going to put the 6.02 times 10 to the 23 atoms of gold on the bottom, and that equals 1 mole of gold. Okay? My atoms cancel and I end up with mole, and that's what I want. So now I just have to do the arithmetic. So I'm going to take 4.5 divided by 6.02. 4.5 divided by 6.02 is equal to 0.747. And then what do I do with my exponents? Well, remember that when we divide exponents, we subtract. So 10 to the 24 minus 23 is 10 to the 1. Okay? Now that is not in scientific notation, so I have to move my decimal over. If I make that bigger, then I have to make my exponent smaller. So that's 10 to the 0 or just 1. And it looks like I have 2 sig figs, and so this would round to 7.5 moles of gold. Right? 7.5 because 10 to the 0 is 1. All right? So hopefully that's a good introduction, and you'll do some more practice in class.